been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This video is for Geometry 5.2 using perpendicular bisectors. So this is a review, but perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. So if I have a segment here, A, B, a perpendicular bisector is going to be, for instance, a line that goes through AB, intersecting at a right angle, and the intersection here must be the midpoint. So C is the midpoint of AB. So that is what a perpendicular bisector is. Notice that a perpendicular bisector cannot be a point. So it has to be a segment, a ray, line, or plane. What is equidistant? Equidistant is when a point is the same distance from two other figures, whether that be a point, a line, or a plane. So, using the example I just talked about, C is equidistant to A and B. Why? Because it's the same distance to A as it is to B. Why? Because it's the midpoint. All right. Circumcenter is the intersection of the three perpendicular bisectors in a triangle. So in a triangle, you can construct perpendicular bisectors, which we will do in GeoGebra. So I'm just going to do a rough sketch here. So I'm going to say that that's the perpendicular bisector of BC. And then this is the perpendicular bisector of AC. And then this would be the perpendicular bisector of AB. And so this point here, where all the perpendicular bisectors intersect, is called the circumcenter. And the circumcenter can be used to circumscribe a circle, which again, we'll take a look at that in GeoGebra. The perpendicular bisector theorem. Okay, so this is a theorem that can be proven that says, in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the points of the segment. So we're going to look at our example from earlier. We had segment A, B, and we had the perpendicular bisector that goes through the midpoint C. And so I'm going to put a point D. So CD, line CD, is the perpendicular bisector of segment AB. And as a result, the theorem says that any point on this line CD, any point here, is going to be equidistant from the endpoint. So what that means is if I draw a line from that point on the bisector to point A, it would be the same distance as if I drew a line or segment from that point to B. So this is congruent to that. That's what that means. And if you'll notice, that completes a triangle there. And so we can use this theorem when we're looking at triangles or any kind of figure that may apply to this. Now, the converse of this is also true. Remember, the converse is if Q, then P. So if a point is equidistant from the endpoints, then it is on the perpendicular bisector. So if I have a line here, and I'll call this segment A, B, and then I have a point here, D, we'll call that point D. If this is showing that AD is congruent to DB, then that must mean that D is on the line that is the perpendicular bisector, meaning that is also congruent to that. So again, if the segments AD and DB are congruent, then D is on the perpendicular bisector. Don't forget that a bisector means it intersects at a midpoint, which means AC is congruent to BC, again, by definition of midpoint or perpendicular bisector. All right, so let's apply this. So it says, given that line BD is the perpendicular bisector of AC. So let's stop there and let's see if we can identify things here. So BD is the perpendicular bisector of AC. So that means that this is congruent to that because B is the midpoint. Also, that means this is a right angle and this is a right angle. And we need to find X, and then we need to find the distance of CD. Well, the perpendicular bisector theorem says that if a point is on the perpendicular bisector, then it's equidistant from the endpoints of the segment. So because point D is on line BD, which is the perpendicular bisector, then that means that this must be congruent to this. Therefore, we can set up the equation 3x plus 14 equals 5x, 14 equals 2x, x equals 7. And then I can plug in a 7 for x to find CD, which would be 3 times 7 plus 14. 21 plus 14 is 35. So x equals 7 and CD equals 35. So I know that we've learned a lot about angles and triangles, and it all seems to run together, but you really need to do your best to try to keep these theorems, in order in your head as far as what theorem says what, because what's going to start happening is y'all are going to want to just start marking things and not really knowing why you're saying that that is true. For instance, why is CB congruent to AB? So just try to really think about why you're doing what you're doing and make sure that it's justified in order for you to do that.
I've been waiting way too long. Yeah.